The Big One Theory, Part 3, Multiplying Fractions. Here's a quick review of what the Big One Theory basically is. For more information, check out the Big One Theory video, that's Part 1. Canceling out fractions is basically canceling out common factors in those fractions, and that's dividing by 1 in the form of a fraction, so it is actually the same thing as simplifying. So it uses the multiplicative identity with dividing. So when you divide by 1, you still end up with the same thing. When we talked about simplifying, you would divide by 1 in the form of a common factor over itself. So in the case of 14 and 16, they both have a common factor of 2, so you divide by 1 in the form of 2 over 2, getting you 7/8. That is the exact same idea behind canceling. Here's an example. We're going to start out doing this conventional way. So you multiply your numerators and your denominators, you just multiply straight across, and you get 12 over 99. Well, that simplifies. If a student knows their multiplication facts well, then they'll know that. When your numbers get much larger, though, it becomes much more difficult to do that. In this case, we're going to simplify by dividing by 3 over 3, which again is a form of the number 1, and dividing by 1 does not change the value. 12 divided by 3 is 4, and 99 divided by 3 is 33. So the simplified version is 4 over 33. That seems like a lot of work. And using the Big One Theory in simplifying is nice, but there's a way that you can simplify actually before you multiply. Here's how it works. So you notice that 9 and 3 both have a common factor. Again, if you know your multiplication facts, that's easy to see. 3, 6, 9. They're both on the 3 scale. So we write them as factors of 3. 9 is 3 times 3, and 3 is 3 times 1. Well, you notice that they both have a 3? That 3 over 3 is 1. The same as 3 over 3 when simplifying is 1. And it's the exact same form of the number 1. It's 3 and 3. So what we're going to do is cancel that out. And we show that canceling by simply marking out those 3's. And then what remains is the other 3 in the case of the 9 and the 1 in the case of the 3. So instead of multiplying by 9 and 3, you're going to multiply by 1 and 3. And you see that you have the exact same answer, but using a lot less writing. Now you might be saying, well, that seems like an awful lot of writing also. And it is. But as we practice, there is a shorter notation, but I never practice the shorter notation first. I always practice the long way until students are able to work it fairly smoothly and at least understand the basics. Then I show them the shorter notation. So in the case of the next example, first you take a look at your numbers that you have in your numerators and your denominators and think about, do they have any common factors? Again, this is all about knowing your multiplication facts. Well, if you notice 6 and 12, that's usually the first one that people would notice. You can do the 5 and 15, but in this case, we're going to look at 6 and 12. They actually have several common factors, 2, 3, and 6. You're going to want to use the larger of the factors because it'll simplify it as far as it will go. So you have 6 times 1 is 6, and 6 times 2 is 12. So the 6's, that's your 1. That's your Big One Theory that you're canceling out, and you just mark them out, and you leave the 1 and the 2. Now you simplify 5 and 15. What do they have in common? Well, 5 is 5 times 1, and 15 is 5 times 3. They both have a 5 in common. That's a 1, because one of them is in the numerator and the other one is in the denominator. You cannot simplify side by side, because if you remember, to make a 1, it's not a number right next to itself. It's a number in the numerator that's the same as the number in the denominator. So one of your factors has to be numerator, the other one has to be denominator in order to cancel out the 1. Well, then you notice on the numerators you have 1 and 1 left, and in your denominators you have 3 and 2 left. So those are the things you multiply. 1 times 1 is 1, and 3 times 2 is 6. So the answer is 1/6. And you did it by simplifying in advance. Now, had you not canceled out, you would have had 30 over 180. And again, those are fairly large numbers, although you could have just marked out the zeros and then did 3 and 18. In this case, it wouldn't have been super hard, but a lot more writing. Here is the shortened notation form. So you still look at the same numbers and you still look for what they're divisible by. In this case, I noticed that 6 and 12 are both divisible by 6. So it's important that you say what it is that you're doing as you do this, especially when you're showing an example to the students. So I say 6 divided by 6 is 1, and 12 divided by 6 is 2. I'm dividing out that 6 over 6, which is still the big 1 theory. It's still 1. I just didn't write it. I'm just marking out the 6 and putting a 1, marking out the 12 and putting a 2. In the case of 5 and 15, I say 15 divided by 5 is 3 because I know that 5 and 15 are both divisible by 5. So I just divide them by 5. 5 divided 5 is 1. Now you notice in the numerator I now have a 1 and a 1, just like before, and a 3 and a 2, just like before. So guess what the answer is? It's the same. It's 1/6. Let's take a look at this one. I'm going to show you both ways. And again, it's important that kids practice both ways. Practice the way where you write what the multiples are and until that gets smooth, and then you write the short notation with it. In fact, I'm going to show you on the next screen, I would actually do them at the same time. So when I was teaching, I would have them do a page of probably 15 to 20 practice problems. When I taught them a short notation, I would give them another copy of the exact same page so they could see what they did when they wrote, like 24 is 8 times 3, but over here they're going to show how they just cross it out and put it 3. Let's take a look at what I mean. We know that 24 and 16 are both divisible by 8. Yes, they're also divisible by 2 and by 4, but we're going to go with 8 because it's the largest. So I cross out my 8s because that's the big one, canceling out that 1. And then 25 and 15 are both divisible by 5. 25 is 5 times 5, 15 is 5 times 3, so I cancel out the common 5. What's left is 3 times 3 on top and 5 times 2 on the bottom, which makes 9/10. They would practice this way, and then the next day I would show them the shorter notation. They'd get the exact same problem, but this time they would do the shortcut. 24 and 16 are still both divisible by 8, so I'm going to divide them by 8 and write it like this. So the 24, I'm going to cross out 24 and I'm going to say 24 divided by 8 is 3, and 16 divided by 8 is 2. And then I'm going to say 25 divided by 5 is 5, and 15 divided by 5 is 3. So it's important that they do it the longer way first so they understand why you're dividing by 5. And why you're writing the number 5 and 3. That way they can see it better. They can imagine it a little better in their head. And obviously the answer is going to be the same because it's still 3 times 3 in the numerator and 5 times 2 in the denominator. Try not to go to the shortcut too soon. They need to understand what they're doing first. So you've made it to the end of the video. Well done. And as you know, kids have to write their work with pencil and paper, and they need to show their work as often as you can get them to show it. And I would not accept papers that didn't have the work shown. If they turned in a paper that had all answers, I'd like to say, great, I've got a copy of one just like this. It's called the answer key. I need to see how you got your answers. And they need to show me the methods that whatever method we're working on. Yes, kids think that you're putting them in jail and that it's not fair. But they're teenagers. That's kind of what they're supposed to do. They're supposed to be pushing back on you, and you hold your boundary because you know what's best for their learning. So get you an extra cup of coffee. Realize that teenagers and sometimes pre-teenagers, they're not going to want to do this. But it is in their best interest, and they will remember it and understand it better. It does take longer to teach it. So you're not going to get through multiplying fractions in a day. You're not even going to get through it in 2 days. I would say you need to spend 3 days or more on multiplying fractions, just doing the canceling and also practicing their multiplication tables. Any questions? This is a method that worked great for me while I was teaching, and I really hope that it works great for you. Please feel free to email me if you do have any questions. I'll get right back to you as soon as possible. Thanks for watching, and I'll see you in class.